a 7,000 kilogram train A going at 50 meters per second collides head on with a 10,000 kilogram train B going 50 meters per second. If train B comes to a stop, what happens to train A? So the first thing I'm going to do is going to draw a little diagram. I have train A here, train B here. The train B is going in the negative direction because you got to think of the X and Y axis. So this is the negative direction. Train A is going in the positive direction. So the first thing I'm going to do is write down everything that is given. Train B, the initial is 50 meters per second. The final is 0 because it says it comes to a complete stop. And mass B is 10,000 kilograms. Then we go to train A, and they give us the initial velocity, which is 50 meters per second, but no final. And mass A is 7,000 kilograms. So the first thing I need to do to figure out what happens to train A is get the total momentum before the collision. So I'm going to use momentum equals mass times velocity, which I have 2, so I have to set it up together as that, and then we're going to put another one right here as seen, and you just add those together. So right here we have MA, which is mass A times velocity A plus mass B times velocity B. So 7,000 kilograms times 50 meters per second plus 10,000 kilograms times negative, because it's in the velocity is going in the negative direction. So this is going to be a negative 50 meters per second because the train is moving in the negative direction, equals negative 150,000 kilograms meters per second. So I come down here, and that's the momentum before the collision. Now that I have the momentum before the collision, we can figure out what the final velocity is, pretty much. So that's X right here is the final velocity that I'm trying to find. So I have the momentum. We're using the same equation, but I already have the momentum. So in this equation, I'm going to plug the momentum in as negative 150,000 kilograms meters per second. And you set it to 10,000 kilograms because train B times 0 meters per second plus, you're going to do the mass again of train A is 7,000 kilograms, but we don't know the velocity for this one. So that's where we're going to come out, and we're going to use this as our variable. So we're going to combine this, and that equals 0. So it's just going to leave us with 7,000 kilograms X. And it's still set to a negative 150,000 kilograms meters per second. So then you're going to divide 7,000 kilograms and move it over to this side. You're going to do negative 150 kilograms meters per second divided by 7,000 kilograms, which comes out to be X, the variable, equals negative 21.42 meters per second, which is saying train A is pushed in the negative direction at 121.2 meters per second.